Hello everyone again to my YouTube channel. Today I will start in this chapter of data cleaning and preparation because as we know all in your world of data we're gonna facing some missing uh, data. So for this reason we need some strategies to detect and handling this missing data. So today with pandas. Pandas has own keyword to represent the missing data is the non-value. Okay, so in this tutorial I will show you with small examples how we can handling this. So let's creating series. Okay, so in the previous sessions on pandas we are see two big data structure provided by this library. The first one is series and the second one is data frame. So let's starting with this small example with series content string values the city. Will I run it? Okay, sorry. Will I will check in the content of this series. So this is the value with I create. Well, so the first thing I will do is to using functions called is nil. So for these functions, return to me test boolean test. Okay, is false or true. So if we have some missing data, so the response or does return true. If we don't have any value, then value, sorry, the return false. So we run it, we run again. Okay, so here as we see all we have false. False does mean we don't have any missing value. Okay, let's continue. So here what I do is I assign the new values as non-value with for index 1. So for this, okay, when I've seen it I will run. Now I will see. Okay, if I check the city, so the non value is coming for this index 1. This is the new value we have here. It's missing. Well, if I apply again this nin or is null function, if I run it, can be returned for me this true value because we have missing value here. Okay, this true does mean we have missing value. Okay, well, let's continue. So here I created another series. Okay, content is non-value here, and we see all. I run it and I check my data here. So we have two non-value. Okay, so here in this example, I will show you how we can filter in missing data. Of course, we have a lot of strategy. So the first one or the first function we have here is drop now. Okay, well, in a real world data, when we try to build in some pipeline of projecting data analytics all, so the last option we have is drop now because uh, we want to extract the more information of our data. So for this reason, we have some strategies to follow it to replace this non-value, like a median, like a mod, like average, or some other methods to replace the non-value with the most frequent value, maybe. Okay, but here the last option we have is the drop now value. Okay, well, just I show it because it's one of the first options as a beginner, anyone coming for to learn the world of data. In the world when we're collecting our data, we gonna face some else value. So for the reason we need to have some strategies to handle. Well, here this syntax is equivalent So here in this syntax, what we have is to return the non-value, the not null value, okay? The not null value, okay? If I run it, I gonna get the same result here. Here I drop the non-values, but here I return just the not null values. The same syntax, okay? Here, see in this syntax is the syntax of filtering in pandas, okay? Well, let's continue. Here also I create a data frame to show you also this the second type of data structure we have or provided by pandas. Okay, if I run it here and they will see and try to discover all this data we have here. Well, this is our data created in this data frame. We have some null value here as we see. Okay, well, also I will apply this function, and I will store this result in some other variable called clean. For example, if I run it now, I will check the content of this cleaned variable, and the result is here. What's happened here? If I return and we see we have or we drop all the non-value. If so, in this example of index 0, we have not any non-value here, but we have non-value here. Let's say and apply this drop now. So this index of 1, we will drop it by this function, and also this one, and also this one, because we have non-value. Okay, well, so by default this function drop all does mean if we have one non-value, this record we will drop it by this function. Okay, let's continue. Here we have another attribute called how. Does mean if apply this drop function on top of my data frame, I will specify what is the parameters or this attribute, what is the value we can give for it. Here I will give it all. That means if I try to drop this record, for example, that means all these values, it will be non-value to drop it by this function. Okay, when I run it here, I will get the same result. Why not is not drop it? Because all this value is not null. Okay, uh, for example, for this index 1, it should be non-value here and here and here and here. Okay, so for the reason is not dropped by this function, because I pass this attribute with all value. Well, let's continue. Here also we have an attribute of axis, because by default the axis its column is record, sorry, that means axis equal to 0 for the records. But if I want to drop some colors, also I need to pass this value axis equal to 1, and how it's all. The same things happen with columns. All these value should be with should be it null to be dropped. Okay, all this value should be null to drop these specific columns. Okay, so the syntax here, that's what's happened, or the logic behind the syntax. Well, let's continue. Here I created with a random function some random functions. Okay, if I run it again, this is our data frame created with random function. So this is the result. Okay, and we see all we have random values between 0 and 1, between 0 and 1. So let's continue. Here what I do, I try to replace some values with non-value. Okay, here I using this ilog function. Everyone interested to know deploy with function can be returned to my playlist in pandas. I explain deploy this function and how it works. So this is a slice. This slice does mean I start from all, okay, all these all these rows to to the at position 2 and 4 and 1. That's mean the colon 1. Okay, so from 0 and 1, 2 is not included, it will be replaced by non-value. And for this colon 1 and for colon 2 here, Okay, I will replace those values with non-value starting from 0 to 4, and 4 is not included. Well, I run this and there is a result here. Okay, well, let's check in our result. So this is what's happened here. For this one here, the fi lock starting from 0 to 2 is not included, of course, because 2 is not included. This is the syntax behind. If I want 2 to be included, I need to be stopped at 3. Okay, well, this is the result. We have non-value here and value here also with the column at name 2. We have 4 nans, non-value. That's what I do here. Well, uh, if I apply again this function of drop now, this is the result. So the result obtained here is two last records, 4 and 5, because we don't have any value here. All the other records is dropped because we have at least one non-value. Well, we have also attribute call. So as we see here, we apply drop function on top of this data frame we created. So the result is return two last records, 4 and 5, index 4 and index 5. Okay, because the other records content at least one non-value. For the reason is repeated by this function, and the result is return two last records. So also we have an important attribute called threshold. The threshold does mean I specify what is the number of values will be not nil to be not dropped by this function. Well, here if I try to pass 2, okay, I run and we see I will get the same result because why? What is the logic behind this threshold? So I should have at least two values here to be not dropped by this function. Okay, here at index 0, for example, we have two values. We have 0.7 and 0.49. Okay, we have two because respect this threshold, respect this logic. Okay, the same things will happen with this one. We have at least two values. The same things will happen with this direct index. But when I change the threshold, I assign a new values 3, for example, and if I run it, I can get the result here. What's happened here? It should have three values here, at least three values. Okay, we have 1, 2, and 3. If I have non-value, not will be dropped with this function because the threshold here, I need at least three values to be conserved or to be not dropped in this function. Okay. Well, let's continue also. So I run here same value, and also what we have one function is important is filna. Filna function help us to replace the name value because in pandas we should so the data structure or series it should be content the non value because that is represented as non-value. Well, the second step come in here when we using, for example, this filna function. What is the logic behind this function? I will to replace all the non-value with 0, for example. Okay, so as we see here, we have non-value, but when I run this piece of code, we have the f filna 0. That means I replace all the non-value with 0. Okay, replace all the non-value with 0. Okay, that's what's happening here. Well, let's continue. Also here, so here we have filna. What's the logic behind it? So this filna also helped me to specify what is the column. So in this syntax, what's happened? Uh, in the filna function, I pass a dictionary of values. So the first key in this dictionary is the colon one. The colon one, I want to replace it by 0.5, and the second one here with 2, I will replace it with 0. Okay, I specify if each of this column it will be assigned with some each value. Okay, some specific value. Well, I run it here and I will see and discover the value. Okay, well, that's what's happened. Okay, here for column 1 I replace it with 0 point, all the non-value replace it with 0.5 value, and for 2 replace it with 0. Well, let's continue. uh okay, run again this if for specifying something. Yeah, here also we have an attribute called method, the method of backfill. What is the logic behind this backfill? So we have here non-value. The logic behind this is we taking this value, for example, and this colon 2, taking this value of 0.25 and duplicate it for all this non-value. Okay, I passed this value for all. This is what's called back file. Back file doesn't mean I take in this value and I duplicate it and I pass it for all those new value. I replace non value with this last one. So the same things happened with colon 1. I take in this 0.8 and replace it, or I replace the non value with this value for propagation. Okay, backward propagation. If I run it, this is what's happened. Yeah, I take in this value and replace it for all these things. The logic behind for this method is in when facing some problem, one of the strategies is to replace the non-value with the most frequent value. That's what's called the mode in statistics. Okay, modes in statistics does mean the most frequent value. Okay, I can replace this all this non-value with the most frequent value. So the same things happen with this one. I think in this last values 0.8 and replace non-value with this value. Okay, I duplicate duplication of all this value. So let's also continue. We will create in the other if here. Okay. Well, in when I replace non-value with the phone, okay, we have non-value. Okay, we have non-value here. So we have also another method called forward propagation, back file. Sorry, back file and forward file. Forward file is the inverse of the last one. Here what's happened if we check our data frame, we have this value here. Forward propagation does mean I take in this value and I duplicate it for other non-values. Here 0.3 is duplicated and I take it, I will replace all this non-value with this value of 0.3 or 0.30. Okay, same things happen for this colon 1. I take in this 0.68 and replace all non-value with this one. So if I run this piece of code, also this is the result what I get. Yeah, this is what's happened. I take in this one 0.54 and 0.54 and replace all null value with this one. It's duplication of these values. Okay. Also, we can limit. Okay, we have an attribute called limit. If I want just to limit some specific null value to be replaced with forward propagation, if I run, does mean in when I limit 2, does mean I want just to replace 2 values, none with value of forward 5. Let's take an example here. Let's return. So we have here 1, 2, 3, 4, 5 non-values here in this column 2. Okay. When I limited here, when I limit here, just what's happened is replace just 2 non-value with forward values with 0.54. Okay, when I use this attribute of limit, I replace just 2, specific 2. So the same things happen with this column 1. I replace just 2. If I want 3, for example, I can change here I replace 3. When I run it, I will replace 3 non-value with forward function. This is what's happened. We have 3. Okay, 1, 2, and 3. The same thing happen with this column 1. Okay, well, here I create other series. So if I run it here, this is our data. Or when I check in this data, sorry, yeah, data. Yeah. So if I run it, so this is our data. Yeah. What they will do here is to apply. We have data. Okay. So we have data dot fill no, and they will replace it by main. Okay. Main. The main statistics. The main functions. This mean okay. I will show you now. Okay. Sorry. In this sentence, I'm checking. Yeah, here I will replace with main. Okay, is data. Okay, here what's happened? All the non-value will be replaced with mean of this series. Okay, and that's what. So what is the mean of this series? If I take in 2 values, we have 1 and 2. Okay, the mean. Okay, let's show you. So here in this data, okay, we have just 2 values. We have 1 and 2. Okay, 1 plus 2. Yeah, okay, 1 plus 2. Yeah. So 1 plus 2 equal to 3. 3 divided by 2 is 1.5. That is what's called the mean. Okay, we apply the summation of all the points we have divided by total. That's what's called the mean. Here in this mean, what is or when we apply this mean, so that is depend of statistics, of course. We need firstly checking the distribution of our variable before trying to apply this kind of functions, because the distribution gives us an idea if this mean is will be the solution to replace or to avoid the non-value or not. That's depend of statistics, of course. That it's the steps it's using when apply the exploratory data analysis and cleaning the data and feature engineering on all these things. Okay, so I hope that's be clear for everyone. Okay, in the next tutorial, I will discuss with you the transformation uh, of data. Okay, how we can apply transformation. Well, thank you and happy learning for everyone. Bye bye. See you again.